The one of bases.
Yes. Did you check out any work about it from the site?
No, the link didn't work.
I thought you could like, I remember there was a meeting that on Friday that were showing us how to do it without
Yes,
following the link, how to visit the still you tried it out and failed? I can't hear you speak. Lynette.
Yes?
Can you hear me right now?
Yes.
Okay. So you mean you tried another way and failed to access the work still? Talk to me, my dear.
I tried the link, but it didn't work.
So I want you to try, like you were trained on Friday, how to check the work on the site. I want you to try it out so that we can have enough coverage, yes? So that we can benefit in this time. I want you to visit and check that work, please, so that you can, because at times you may find that there is a content that is easier for you and I may dwell on it knowing that it's quite hard. So that's why I advise you to check on that work before we meet. Okay, Lynette?
Yes.
All right, I'll be glad when you go there, try to go through that work so that we can have enough coverage, please. Hafi, can I hear from you, please? Hafi? Hafi, can you hear me speak?
Yes, I can hear you.
Okay, tell me something. Did you try to check the work about bases from the site? Hafi? Okay, you tried, but you had network issues. So which areas did you identify that they needed the help of a teacher?
No, after it was taking a lot of time, so I could not even access it.
Okay, you're going to try out one more time. I'm going to be sharing my screen soon. Previously, we're going through the introduction. That is about bases, base names, digits required, how to add. Let me try, we're going to try out subtraction and see what we need to, what comes and how we need to deal with it, okay? Previously, we said when you're subtracting, still, there are some things that we mentioned out that we need to always consider. And I hope we tried out some numbers. Let us try to, you're going to try to visit the site so that you can have access to that work that is there. your attempt, you can then you send me the feedback so that we can have at least that fast moving when we are having our engagement. Okay. So I'm going to share my screen. I'm going to share my screen. We talked about all these, the base names. This is just going through binary base. What does it mean? Ternary, base fork or ternary. We looked at all this last time. We looked at the special names of bases and the digits that are used in that base. Centenary base, that is base 6, septenary, octo base 8, base 9 nonary, base 10 having a lot of names. I went ahead and looked at operation, and at least now we can add bases. Lynette, can you add?
Yes.
Okay. Then, Hathi, can you also add?
Yes.
All right. Now let us see how to subtract bases, okay? This one is addition. We've said that we can all add and come up with correct answers. Now let us see how to subtract. When we are subtracting, there are two things we need to consider. One, you consider the digits in each place value. Although we are in bases, still each digit stands under a given place value. If we attempt to give place values to these, we shall have them as, we shall have this one as ones, fives, fives. Why do we say fives, not tens? We say fives because we are dealing with base 5. We are dealing with base 5. That's why we are saying fives, not 10 and hundreds. So the base name helps you to give the place value to each digit as it appears. That is for the case of the base, giving place value to bases. So when we are adding or subtracting bases, those are some of the things we need to consider, the place values of given bases and how we can deal with them. Each digit, we start from the ones or from the right hand. When you're given an order like this is horizontal, so you need to arrange it again. Vertically and make sure each digit corresponds to its place value. Each digit is corresponding to another digit in that very place value. So when we are subtracting, this is very simple, but always remember that you need the side work with you. All you can call it side work, all part of the work, part of work. If we say part of work, it doesn't mean go and put it somewhere that someone won't see. You may find that you've calculated so well in the side work and you fail the answer. So you may find that at least the examiner will say, oh, this person calculated well. Then you can have a mark at least. But if you just come and put the answer here, you find that the examiner will be doubting whether the answer is, whether you did the work by yourself or you got the response from your neighbor. So when we are subtracting, we start from the ones here, from the right hand here. This is where we start from. So we shall have 2 minus 2, giving us a 0. You come and put it here. You move to the next, we have 4 minus 0. Giving us 4. You come and put it there as your answer. 3 minus 1. Giving us answer 2. Come and put it there. Then the base name, 5. Then one thing we should always note, when you're dealing with bases and you are subtracting, there is no incidence that can happen and you have an answer that requires dividing. Let us take note. Unless you've added or you've subtracted wrongly, that's when you can have an answer that exceeds the base given. Yes? Even if you go on and regroup and do what, still the answer will fall in that bracket. That's one beauty about subtraction. Let us see another example here that requires us to regroup. The response here is this. Then let us see another example that may require you to regroup. Say subtract 1, 2, 2, 1, 3. Subtract 1, 2, 2, 1 base 3 minus 1, 0, 2 base 3. So what do we need to do in this case? Arrange it vertically. Now after arranging, still come and remember to put your part of work there. And we've said that we can call it part of work all, the side work. Come and put it here. So you can call it side work, all, part of work. Oh, part of work. You can call it either side work or part of work. This one requires your side working. The one you may think of putting it maybe on the other small piece of paper. In mathematics, we don't need to practice from the other side. Come and put your work in there as your part of work, all your side work. Now we come here, we have 1 minus 2. Lynette, can you give me the answer? 1 minus 2, what do we get?
It's impossible.
Are you sure? Lynette, you mean we cannot pick 2 from 1? Happy, is Lynette telling us the truth? Or you have no idea? Oh, thank you, Lynette. So when you're given 1 minus 2, you realize that you will get a negative. It's not impossible, but you can get a negative. But in bases, we don't have negatives. That's not our interest. And one thing you should not conclude with is putting an answer here without looking at the rest of the digits in the different place values. Yes? So we cannot come here and say, oh, the answer is -1. No. What about when you look at the next digit? Yes? So it's not fair to conclude without looking at the next digit. You realize that when you have 1 minus 2, it will push you to a negative. You say, no, let me check the next neighbor. What does the neighbor have? The neighbor has 2. The neighbor has 2. Yes? So when you move to the neighbor this time round, you pick, you're picking 1 from the neighbor, but, yes? But when you're dealing with a base, yes? Whatever you pick from the neighbor, Okay, Hathy tried and got 1, 1, 1, 2, base 3. Okay, we are going to try it out, Hathy, and see whether the answer is correct. Yeah, Lynette, you will still go through that course, okay?
Yes.
Yeah, it's okay. So, Hathy, we are going to see whether the answer is right. So when you come here from the, remember we have 1, check the neighbor has 2. So the neighbor will remain with 1 here. But whatever you pick from your neighbor, yes? It is equivalent to the base. So here we shall have plus 3. So here we shall have 1 plus 3 bracket minus 2. 1 plus 3 we get 4 minus 2, giving us answer 2. So when you're dealing with bases, whatever you pick from the base, from the next place value is equal to the base name, yes? If you're dealing with base 7, if you go to the next digit and pick a 1 from there, yes?
Yes.
You pick, because remember when we are dealing with base 10, you realize that you pick a bundle of 10, yes? Whenever you go to the next place value, you have a 10, you have a 10, you have a 10. But when you're dealing with bases, everything you pick from the neighbor and you regroup is equal to the base name. So if we had base 7, that means what we would have picked would have been equivalent to 7. So we move to the next, we have 1 minus 0, giving us 0. Oh, sorry, giving us 1. You come and put it there. Then we have 2 minus 1, giving us 1. You write it there. Then we have 1 minus nothing, giving us 1 still. Still, this is 1 minus 0, you get a 1, base 3. So, Hathy, I hope you have seen your answer is right. Lynette?
Yes.
Yes.
Lynette?
Yes.
Have you now seen how we can subtract bases?
Yes.
Okay. So you're going to find some more numbers when you visit the site, and I'm going to attach the assignment today. Okay? So you're going to first find very many different numbers of, that require regrouping, that require picking from the neighbor. Because when we say borrowing, it means you have to you have to pay back. Yes? If we say we are borrowing from the neighbor, it means we have to pay back to the neighbor at a certain point. But when you pick from the neighbor, you have picked. The neighbor has given you automatically, you don't take back. That's why we say pick and regroup. Pick from the neighbor and regroup. Pick one from the neighbor and regroup. We don't say borrow from the neighbor and regroup, because the neighbor will say, oh, when are you paying back? Okay. So we shall try out some numbers of this kind. Then Hathy, what else did you discover that in that work after subtraction? Hathy? Hathy, I want to hear from you speaking. Hathy, can I hear from you, please? Lynette?
Yes.
You've told me you've seen it now, okay?
Yes.
Okay. So which other area, apart from subtraction, you've seen the operation, actually bases, there are mainly 2 operations that are always common in our papers. What that is addition and subtraction in bases. But you find that there can be multiplication. And how do we go about it still? Let's see something here. If I see something here. Here we've seen the final answer. These numbers we shall be trying, they are all there. Be trying. Then there are some instances where you find that they've told you to add 1, 0, 1, base 2 to 2, 1, 0, maybe base 4. When you're dealing with operation on different bases, yes?
Yes.
Addition and subtraction of numbers of different bases. We can also see this, but basically they still tell you in which base they want the final answer, okay? They may tell you that write the answer maybe in base 3, the final answer in base 4 or base 2. So there we shall see what happens. Then there is also an area that I wanted to go through so that you still can discover a lot about it. And this one will help us when we are dealing with operation on different bases. Because in primary 6, we have to discover all that. So there is changing from non-decimal bases to base 10. When they talk about non-decimal bases, who can identify some of those bases they're saying? Lynette, one base, tell me one. Non-decimal base. Yes, Hathi?
Base 2.
Base 2, thank you. Can you tell the special name for base 2?
Binary base.
Wow. Thank you so much. Lynette?
Yes.
Give me one, another non-decimal base. The ones that we consider non-decimal bases. Hath has told us base 2 and its special name, which is right. So you also give us one, please. Okay, non-decimal bases range from 2 to 9 at our level. You will know why I always say at our level, because you realize as we keep on moving, the work keeps on changing. Yes? As you move on, remember before you looked at something small, but now it goes, it moves like that. So when I say at our level, I mean just here, because you find that there are some other bases, base 11, base 12, 13, like that. But non-decimal bases at our level, we have base 2 to base 9. And here they are saying changing from non-decimal base to decimal base. So what we require to know, one thing when you're changing from this, you need to know how to give power. Let us see an example here. Change 1, 1, 2 base 3 to decimal base or base 10. Whenever they talk about decimal base, just know, yes, Lynette, thank you, I've seen your answer, good. Base 3, yeah, that's good. Change 1, 1, 2 base 3 to decimal base or base 10. When they talk about this, they tell you to change. One thing you should always know is to give powers, yes? It's a matter of expanding this number here using powers. And coming up with a final answer, don't just leave it hanging. Because when you're expanding, you don't work out the final answer. But in this case, you find that why we are saying teacher is not talking about the what? the place values. The place values, we have them ones, base 3, then this one will be 3s, then this one will be 3 3s. As this one here, when you're giving, what helps us when we are giving powers? One, the number of groups you get from the given base. You find that in ones, when you're grouping in ones, ones is equivalent to a 1, yes? We all know that. The ones place value is equivalent to a 1. Then this is equivalent to, the 3 is equivalent to number 3. So you find that there is only one group, there is 0 groups of 3, yes? So when we are giving powers, like we have expanded using powers, you find that you begin from 2 to power 0, 10 to power 0. Why? There is no group in that section, group of 3. Then when you move to the next, you find that there is a group of 10, yes? You find that when you draw this O, you find that there is a group, a complete group. Under this place value here, that is the 3 here. Then here where we have 3 power 2, you find that this is the place value that is 3 3s, meaning that it's standing for 2 groups of 3. So when we are giving powers, we start with power 0, the first place value here. The first place value for this one here is 1s. So you find that we are giving powers to the given base, that is 3. The given base is 3. So we give powers to 3. So we shall have 3 power 0, 3 power 1, 3 power 2. So if you're still continuing with other digits, you'll have 3 power 3, 3 power 4, 3 power 5, 3 power 6, 3 power 7, like that. They just keep on continuing. So after giving them powers, there is something simple you just do. You multiply each digit times the base and its power. When we talk about the base and its power, we mean the 3 and its power, that is 2 here. Like that. So we shall have 1 times 3 power 2 in 2 brackets plus 1 times 3 power 1 plus 2 times 3 power 0. Then after there, we expand. After there, we expand the powers. We expand. So you find that 3 power 2 is the same as 3 times 3. The power shows how many times do you multiply that given base. That's what the power is showing you. So you find that you have 1 times 3 power 2, showing that you're multiplying 3 2 times, not the power 3 times. That's wrong. Some of our colleagues fail to interpret this simple thing here, where they have 3 power 2. You find that someone says this one is 2 times 3. Some say this, and some others, you find that they will say, teacher, this means 2 times 2 times 2. So in this case, what do we need to understand? You find that you need to know that the base is multiplied according to the number of times the power holds. Yes? The base is multiplied according to the number of times the power holds. If the power is 6, that means you will multiply the base 6 times. Which one refers to the base? This one here, 3 is the base and 2 is the power. It can be called the exponent, it can be called an exponent. It can be called the index or the indices. We can call them exponents, we can call them powers, anything you wish to call them. But in this case, what we should know, what stands for what, this case, we have 2 is the power and 3 is the base. So whenever you're dealing with this, so after expanding, you can work out the brackets, and so you'll come up with the final answer, and the answer you get will be in base, 10. Don't say 14 decimal base, say 14 base 10. Unless someone has something to say. I want you to you're going to go and visit more the site and check under that unit. Just go and check that bases, it's separate bases. It's a unit on its own. It was added as a unit there. Try to go through those numbers and check, go through them. Lynette?
Yes.
Is there anything you would like to talk about?
Yes.
Okay.
If on 2 times 3 plus power 0 isn't it supposed to be 2 times 0?
No, any number to power 0 is a 1. Actually, we are going to look at them more when we look at the indices. I hope you've already seen a topic there, a subtopic that is about indices, the rules of powers. We are going to learn more about it. This one is just something brief to help us cover the bases. But when we look at the indices, we are going to see why is 3 power 0 equivalent to a 1. Why is it that we multiply 3 power 2? Why is it that 3 power 2 is the same as 3 times 3, not 2 times 3? We are going to see that when we look at the indices, we are just having some little knowledge here that we just need to pick up, but we are going to understand it more when we are dealing with the indices. We are going to understand really. We are going to check and see, why is it like this? Why is it like this? Why is it like this?
Yes.
Because remember, any number to the 0 power, yes?
Yes.
Hath, are you saying anything? Hathi?
Yes.
Is there something you would like to share before?
No.
Have you picked up something today?
Yes.
All right. So try to go and check that work so that you can cover something. Then next time we shall discuss of how to change from this base to this one. What do we need to do? What do we need to consider? I'll just be giving you those tips and they'll help you move through. Otherwise, I wish you a nice morning. Bye-bye.
Bye.